Welcome to the Standards Update webcast. This webcast topic will be IMF, the Interoperable Master Format. The webcast is part of SMPTE Standards series. It's a quarterly webcast designed to inform about significant SMPTE Standards development, and IMF is one. It is open also to members and non-members alike, and it is powered by SMPTE's Professional Development Academy. And let's see, we'll move on to our guest speaker, Annie Chang, who is Vice President Post-Production Technologies for the Walt Disney Studios. She's put together a great presentation for today. Hope that you find great value with it. Annie, without further delay, the floor is yours.
Thank you, Joel, and thanks to SMPTE for having me today. And I have to apologize in advance. I'm a little under the weather, so hopefully I won't be sniffling too much through this. But today what we're going to do is we're going to cover a few things. We're going to talk first about what the actual problem is. Then we're going to talk about what is IMF and what actually is it and what is in it. And then I'll give you an update on the SMPTE standards of what's going on with the work for IMF. So first, let's talk about the actual problem that we're trying to solve. So what I'm going to describe here is a simplified version of a typical post-production workflow. This can work usually for feature content or episodic content, but it is highly simplified, but it'll hopefully get you an idea of where we're at in the post-production process. So regardless of whether we're starting on film or a digital camera, you basically need to look at your files first. So we'll take a look at the dailies content, which is the things that we shot for each day, and just make sure that the performance and the framing and the color and everything is correct for what we just shot. We'll take that, we'll throw that into the editorial process and start cutting together the content. And then once we actually have a picture lock, or at least pieces of the sequences that we want, we'll create an edit decision list and throw that into our digital intermediate process, or DI. And this is where we actually conform back to the original camera files. There are some episodic shows that just finish through the editorial process and actually never hit the DI process. But for the majority, at least for our ABC shows and the Disney shows, the feature workflows, we actually conform back to the original camera footage. Now, as I said, this is oversimplified. We also have visual effects and other things that get created and put into the digital intermediate process as well. But in general, that's the quick overview of the actual post-process once we're done shooting. So then what we do is then we'll take the sound, record it, do some dubbing, do some mixing, and then once again, highly simplified, but create different language versions of the audio to match with the picture. From the theatrical feature workflow, we'll create a couple of different outputs. We'll create a film out, which has all the different languages. Then we'll create a digital cinema package version, and then we'll do a separate color timing session to create a bunch of different HD masters. For an episodic workflow, obviously there is no film out or digital cinema packages that are created. They would just go straight to this Rec 709 HD master. But the HD master is the interesting part here, and this is the part that we're really going to focus on today, because that's the one that actually perpetuates into a whole bunch of other downstream distributions, like Blu-ray or electronic sell-through. We can make standard definition masters. You have VOD, broadcast, satellite, cable, all those different types of things. And from the HD master, you're also creating other file formats to deliver to these downstream distributions, including tape and other more compressed files for each of these different distributions. And the issue that we're having really here is that there are a lot of different file formats that are out there, and that's part of the problem that we're trying to solve here. So we're going to take a look and focus directly on this HD master and the downstream distribution. And as you can see, the problem that we have for content owners is that, as I mentioned, there's multiple file formats for the master in general. So we could have tapes, we could have ProRes files, you could have DPX frames, you could have MPEG-4s, you could have MPEG-2s, all kinds of different files. But it doesn't just stop there. Besides the actual file formats, we also have different versions and edits that are needed for the actual content. So on the feature side, we'll create a theatrical cut. We could make director's cut, airline edits, TV censor edits, those kind of things. There's different types of versions that are created of the actual content. Then add on to that, you've got different frame rates, different resolutions. We've got different aspect ratios, because let's say we, for a feature show, we'll actually create a show that's in a scope format, or also known as 239 or 235 or 240, depending on who you're talking to. And then we'll take a pan scan of that and create a 178 and a 133 master to work with the different television aspect ratios. Then on top of that, you might want to add on a bunch of languages. For our Pixar and feature animation content, we'll create up to 42 different languages, both subtitled and dubbed. For these different file formats, we actually have to create long play versions of each of these different languages. And then on top of that, you're adding in your aspect ratios and your frame rates and the different cuts and everything. You can see how this starts to perpetuate. And of course, then we distribute to many different companies and different types of formats. So you have a lot of other file formats, which creates basically an asset management nightmare. So this is kind of the problem that we're trying to solve here, just because there's so many different variations of this HD master. So going back to this post-production workflow, the way we see it in the future is that this multitude of file formats would be converted into an IMF. Any kind of standard definition master would also become an IMF. And so then the idea here is that perhaps some of the downstream distributions wouldn't actually need to take a specific file format. They could maybe take IMF directly, maybe the tapes can go away, and those companies downstream can take IMF directly as well. And so this is where we start getting some power from the IMF, from this file format, because basically if we can get rid of some of the file formats, then that actually reduces the amount of files that content owners have to create. You'll see that we still have to create some other compressed file formats, so there's no way to completely eliminate all of the file formats downstream, but at least if we can reduce them, that would be helpful. In the future also, just to kind of give you an overview of how things would go, film would most likely go away. And our DI process will hopefully be standardized by another process called ACES, the Academy Color Encoding System, which is also getting standardized by SMPTE as well. But this is what we see as the future workflow for at least our feature workflow, where we have ACES in the digital intermediate side. You still have the digital cinema packages because that's a specific color timing for the theatrical environment. And then we have the different color timing for the HD masters, which would actually be IMF. So it's ACES to digital cinema packages and IMF. And you can see how the rest of the workflow really isn't changed at all from the post-production side on the left-hand side of the DI process, because none of that really needs to be changed. It's really just more so standardizing the DI and the distribution masters after that. So let's talk a little bit about IMF. So IMF used to stand for the International Monetary Fund, but no longer. It is now the Interoperable Master Format. And what that is it's a single interchangeable master file format. The idea is that IMF minimizes storage because we can use a mezzanine level compression. Where you actually get the big bang for the buck is that you can store the differences between your versions. So instead of storing flattened long play versions of each language and each aspect ratio and each of these different types of versions, you could actually just store the differences between the versions. And we'll go into more detail about how that works. The key to IMF is that it has very flexible versioning, and it does allow for automation for downstream file transcoding. But the big thing with IMF is that we did not want to reinvent the wheel. We wanted to reuse existing standards where it was possible. IMF is actually loosely based on the digital cinema SMPTE Standards, which has a proven track record of working in the field. And the idea here is that it's interoperable because we're using constrained standards. So, well, I'll explain what I mean by that. But basically, the standards are locked down tighter so that it's easier for manufacturers to create the ability to use IMF. So I'm going to stop for a second and give you guys a little bit of history on IMF, just so you know where it came from, that it was actually hopefully somewhat well thought out. Back in 2007, the Hollywood studios were talking about the need for a distribution file format. We could already see that there were going to be a lot of different file formats on the horizon when it came to this HD distribution. So in about 2008, the University of Southern California Entertainment Technology Center created a safe homeroom for 5 of the Hollywood studios, and later on Universal joined too as well, so there were 6 studios. It created a room, a place for us to talk in an antitrust environment where we could talk about the file format. And so we argued basically for about 2 years trying to figure out what this file format would be and what codec we should use and what did we want in this, this format and everything. And originally it was called the Digital Video Package, or DVP, but along the way we changed the name to the Interoperable Master Format. In February 2011, the USC ETC published the first version 1.0 specification for IMF. That was the culmination of the work that all the 6 studios had done together. And then in March of 2011, SMPTE started work on the actual IMF format. And I know that sounds like, wow, this was so organized and everything. Well, we knew that the specification input document was going to be coming up. So in December of 2010, we actually started work at SMPTE to get IMF prepared for the SMPTE work. And so by the time the document was completed in February, SMPTE could actually start the work in March. So let's now drill down into what IMF is. It is business to business, so it's never really meant to go to the consumer because it is sort of a larger package. It is a high quality final master that is file-based. It would contain image, audio, subtitling, captioning, your metadata, and different playlists. And the original intent of IMF was that it was a grand master, that it would also contain all the different cuts and versions, including all of the different language versions. But even this original intent is starting to evolve. We're seeing other use cases besides just for the content owner for that grand master. But this is the original intent of what IMF was trying to solve. What IMF was not meant to be was that it was really not meant to be an origination format or for live-to-air production. So it's not really meant from a news standpoint, for example. It's not really meant for camera output, dailies, or editorial. It doesn't mean that you can't use IMF for those purposes. It's just that it wasn't the original intent. We were trying to solve a specific other problem that we had that I showed you earlier with the distribution master. And originally it wasn't actually meant to be a final package that we would deliver to a distribution, but now we're seeing that it could be, and that downstream distributions might just take IMF directly, which would be great because it would also be a savings for them on their part for their asset management. And of course, for IMF, the idea was always that you could create other tapes from it, you could create other smaller compressed files from it. So it was always meant to be this interim mezzanine file format that you could actually create other stuff from. And it had to be high enough quality, of course, in order to create those other downstream file formats and tapes. Also, IMF is actually not meant for archive. What we mean by that is that archive elements usually require other parameters such as error correction or how the data is written so that you can read it back in about 100 years from now. We weren't trying to solve all of the problems with archive. We're hoping that something like the archive exchange format, or AXF, would actually be something that would be used for that, and you could use IMF in an AXF. But the idea is that you could still use IMF for archive. It just doesn't include parameters such as error correction and that sort of thing. Once again, we're trying to solve a specific problem having to do with the HD and just basically the home video and television masters. And just from a side note, for Disney's standpoint, we would actually consider IMF as one of our archives for our home video masters. So let's jump into like where this is at for the standards process. So we have a working group at SMPTE. I'm actually the chair of it, and the group is called 35PM50. I have several ad hoc groups that are actually drafting different parts of the standards documents. IMF is actually a suite of documents. So I have several different groups doing that for the drafting, but then I'll talk a little bit too about this other group that's actually not creating any standards documents, but is actually working on Interchange, and I'll talk about that later in the process. But we do have lots of involvement from lots of companies. We have major studios and broadcasters. We have lots of manufacturers, lots of vendors, and post-production houses involved. And in total, at my last count earlier this week, we have over 200 members from 122 different companies, and then plus freelance consultants that are actually not associated with a specific company. All right, so going to go right into the actual IMF format and what's included in it. So we're going to go into detail into each of these parts, and then I'll explain a little bit about the flexible versioning and how this actually works in some more concrete examples. So just overall, some key concepts of IMF is that we have essence wrapped into track files. The essence being image and audio, we call subtitles and captioning data essence, and then we have any kind of metadata that changes over time, we call that dynamic metadata. So each of those essences would be wrapped into these track files. We have this other notion of compositions and composition playlists, or CPLs. This is where you get your versioning, and this is where the strength of IMF comes in, because it basically creates a very flexible hierarchy from combining and synchronizing the track files. And then unlike digital cinema, we actually created something new for IMF called the output profile lists, or OPL. And this will include global output parameters like transcoding parameters and things like that. So I'll explain a little bit more about that in a little bit. And then we also have the concept of packages and security, which is another couple of concepts that were borrowed from digital cinema. So let's just jump into essence right now. So in order for an essence to be an IMF, it has to be a standard because IMF is a standard, and so it's a little bit difficult to create a standard based upon a proprietary format. So for example, the image can be compressed or uncompressed. It could be any size, resolution, frame rate, etc. But it does have to be some type of SMPTE or ITU or ISO standard in order to actually be an IMF. So one of the questions I get a lot of times is there going to be ProRes in IMF? And because ProRes is a proprietary format, it's a little difficult to put that into IMF. But there are plenty of other codecs that can be used, like MPEG-2 and MPEG-4, JPEG 2000, etc. Right now, the audio is 24-bit uncompressed PCM, and you can use any number of channels and sound fields. We do use MCA, which is the multi-channel audio labeling, in order to label those channels and sound fields with the metadata in the MXF wrapper. For the subtitling and captioning, also known as data essence, we're using the SMPTE time text, or also known as ST 2052-1 format for the time text. And for those of you that aren't as perhaps you're more visual learners, I have a couple of analog images here that we can kind of associate with what I'm talking about here, because I know sometimes this can get kind of esoteric when we're talking about essence and wrapping and that sort of thing. So let's make this a little bit more fun. Okay, so let's talk about essence in general. So let's think of essence as a chocolate bar. So everybody loves chocolate, right? Except for those of you that might be allergic. Okay, so maybe you won't like that. But anyway, so the chocolate is there it is, but you don't know, is it Hershey's, is it Ghirardelli, is it dark, is it milk chocolate, what is it? You just know that it's chocolate. Okay, there's that. Oops, hold on a second, sorry. There we go. Sorry, just having a little bit of an issue here with my oh, sorry, hold on a minute. I had a little bit of a problem with my PowerPoint here. Okay, all right, so now we're going to move on to wrapping here. So the essence and the metadata that we have in IMF is wrapped in something called MXF OP1A. And in fact, what we're using is a version of MXF OP1A that was developed by the Advanced Media Workflow Association called ASO2, or the Application Specification 02. There's some slight modifications from it, but basically that's what type of MXF wrapping that we're using to wrap around the essence. This creates track files, and also holds the pertinent metadata around that essence. And MXF wrapping is great too, because it's a standard and it allows for other compression schemes to be included. So as long as that codec can be put into the MXF generic container, like MPEG-2 and MPEG-4 and JPEG 2000, you could actually use this MXF wrapping in IMF. And also, just so you know, as a general, MXF also wraps all of the audio channels into one file. So if it's a 5.1, you don't actually have 6 different separate files. You actually have it wrapped into one 5.1 file. So in our analog comparison, you could kind of think of the chocolate bar as having a wrapper. So now we know it's a Hershey's bar. We know its weight. We know its ingredients. We know how bad it is for you, and we know it's regular milk chocolate. So it has a lot of metadata in the wrapper that explains what that is. Same thing as if we had a marshmallow. Maybe it's, oh, look at that. We have a Kraft Jet Puffed, and it tells you that there's X amount of marshmallows inside the bag and the ingredients for that. And then if you had graham crackers, you would also know, oh, okay, that's honey made, and you can see how many are in the box and what are the ingredients are for that and the weight and everything like that. So the wrapper actually gives you a lot of metadata about the actual essence. Now moving on to the next part of IMF, which is the composition playlist. Now this is very similar to the digital cinema composition playlist. So those of you that are familiar with digital cinema, it's pretty much a copy and paste from that. But basically the CPL ties everything together. It basically provides synchronization for all of the essence and the dynamic metadata track files, which we will talk about in a little bit. The CPL is readable as XML, and instead of using directory paths, it uses something called the universally unique identifiers to reference the different track files, and also the CPL itself has its own UUID as well. And it can generate its own time code as desired. And so you can think of the CPL as an iTunes playlist type of thing. It basically ties everything together and provides the playback order of what you're trying to create as a playback. A composition would be basically taking the composition playlist and then one or more track files to create this thing that we call composition, which is basically a completely self-contained digital media program. So for example, a feature would be a composition, or an episode, or a trailer, or an advertisement. Each of those could be its own composition, and it would have the track files and then the composition playlist that creates the proper recipe of the playback for that. So in our case, what we could do is we could take the graham cracker, the marshmallow, and the chocolate, and we could put it together as a recipe and say, now put together this way, and that creates a s'more. And so that actually is kind of the analog equivalent of that. Now, there is something new in the IMF that's different from digital cinema, and that's the output profile list, or the OPL. And what this is it's basically a set of global information or instructions that specifies a certain output preference to a downstream device. So what that means is that we can have these instructions that affect the entire CPL to actually do something with that CPL. So the idea here is that the OPL would also be XML. You can have many OPLs that are linked to one CPL, or you could have one OPL for many CPLs. So you can kind of mix and match how you actually want the OPLs and the CPLs to work. There's different types of OPLs. We have a simple output profile list, which would basically be like whatever that CPL says, just play that composition playlist as you see it. Or you could have more complex output profile lists. The idea here is you could specify different parameters. So for example, we could have different preprocessing or color space conversions. We could talk about having encoding and transcoding parameters. So you could actually put in specific profiles. Say you have a specific file format for someone downstream. It's an MPEG-4. low complexity with an AAC audio encode. Well, you could put those different parameters and the bit rates and what you actually need into the OPL and then just reuse that each time for the different CPLs. Another more complex version that I like to explain to people is that Pixar animation is very particular about how you would get from, say, a 444 RGB 10-bit down to an 8-bit 422 file, and they have specific a specific order of what type of filters and when you actually do the color space conversions, when you do the chroma subsampling and that sort of thing. So they could actually list out their preference in this OPL. And the OPL does take a little bit longer for us to develop because you do need to create that common language between transcoders so that each manufacturer can understand what you're trying to do and then translate that properly into their systems. So in our analog comparison, we could just say, take the CPL, which is that SMOR, and eat it. So that would be an example of an OPL. And now keep in mind, an OPL works globally on the entire CPL. It doesn't actually do things in like reversion anything, or it doesn't cut up anything and play things differently. That's the job of the CPL. The OPL really is supposed to take the entire composition and then do something with it. All right, so I don't really have a analog equivalent or any pictures to go with this dynamic metadata, so I kind of put this up to the side here. But dynamic metadata would be an essence file where the metadata changes on a periodic basis. A lot of times it may change like every frame or every other frame changes. So an example of dynamic metadata could be time code, could be color correction data or 3D related data, so stereoscopic type information, pan and scan, or even descriptive metadata where you're explaining that there's certain objects in the in parts of the screen at different times of the content. So to give you more examples on a specific example of dynamic metadata, one of the things that we were talking about is having pan and scan dynamic metadata. And in this case, what we would do is we would have a full aperture image, just one of them, for the track file for the image side. And then from that, you would actually create your different pan and scan versions. So as I mentioned earlier, we could create a feature in scope 235, and perhaps you have then the pan scan information to make the 178 and the 133. So using tilt, pan, zoom in, zoom out, squeezes, both horizontal and vertically. The idea is you could have multiple pan and scan metadata tracks in an IMF. Using this one set of image, you would have basically, in this case, 3 different pan and scan metadata tracks, one for 235, one for 178, and one for 133. And then the last couple of things that we have for IMF is packaging and security. So the packaging idea is basically creating an interoperable master package. And all that is it's a collection of files. You have the composition, which includes the CPL and the track files. You have your output profile list. And then you have these 2 other files that, once again, were borrowed from digital cinema, which is the packing list and the asset map. The packing list basically tells someone that's receiving this IMP, the package, that here's a list of the files that you should be expecting, just like a packing list that you have when you get a delivery from UPS or FedEx or one of those other type delivery places. The asset map basically takes the files and maps the information from the UUIDs to the actual physical files that are located on the particular media that you're actually moving the data to. So if you put the IMP on a hard drive, the asset map contains the information to basically map the UUIDs to the actual physical files on that specific hard drive. And the last thing we have is security. We have digital signatures for both the CPL and the OPL, basically any of the XML structures. And we have been talking at SMPTE about adding encryption, just like there is in digital cinema. We did decide in SMPTE to just go ahead and push off that discussion for a little bit, just so that we could go ahead and get the main portion of IMF complete, and then we'll worry about the encryption portion later. So just to summarize the structures that you're seeing with IMF, is that basically we have this composition playlist, which is like an edit decision list or a recipe. It points to various track files that synchronizes and creates the proper playback of the content. And these track files are just essence like image, audio, subtitles, and closed captioning and the dynamic metadata. And it's wrapped in this ASO2 subset of MXF. And of course, this wrapping creates all that metadata that we want to have that explains what exactly is inside the track files. All of this creates a composition. And then in addition to the composition, we have that output profile list, or OPL, which creates your transcoding and conversion instructions, that asset map that I talked about, and the packing list. And together, these all create the IMP, or the Interoperable Master Package, that you would then deliver to someone else. Okay, so now that we've talked about what exactly is in an IMF, I'm going to talk more about specific use cases of how you would use the versioning and where the power of IMF comes into play for content owners. Here are a couple of screen grabs from one of our movies called Tangled. And as you can see, what we did is we took the main title and we actually converted it and translated it to different languages. And we actually do this in up to 14 different languages where we have the main title translated. So this is actually in the movie and it plays. And then if you were playing the French version, you would never see the English title. You would actually see the French title instead. And then, of course, since we have dubbing for the audio, we have to give credit to the artists that did the audio dubs. So we'll have dub credits at the end of the movie to give credits to those people that did the languages, did the dialogue. And then within the movie, we will also translate several of the inserts that we have. So in this case, we translated the wanted poster into the 14 different languages and had those specific to those language versions. So the thing is that because we have the main portion of the movie hasn't been changed, but you do have these inserts, it's for IMF's standpoint, the great thing about that is that you can actually do a bunch of versioning, but like I said before, you only save the differences between the versions. So I'll explain how that works here. So let's say we have this English version of the movie. It has the English title, your main video, and then your English end credits. Just for simplicity's sake, we have English 2.0 audio and we have the English closed captioning. So this would be a version that we would use perhaps in the US, for example. So we would create a composition playlist that points and references to these different track files. And then in order to create a package, we would just create maybe a simple output profile list that would point to that composition playlist and then say that is the English IMP or English Interoperable Master Package. So let's say we take these files and we send them off to someone downstream, like perhaps like a Deluxe or a Technicolor, for them to service our files. All right, let's say now we have the English with the French subtitles. So we have this new French subtitle track. We'll create a new composition playlist that basically refers back to all of the track files that were in the English package, but now includes this new asset, which is the French subtitles. We could create a new output profile list that points to it, but you can see that we wouldn't have to resend Deluxe or Technicolor the English package as well because we've already sent that to them. So instead, we can send them a supplemental or a partial package that just contains something that's different from the English package, which in this case would be the French subtitle track, this new composition playlist, and this new output profile list. All of the English files that this composition playlist needs would refer back to the English package to get those track files. And I know some of you might be thinking, well, this is magical that you can do it this way. But actually, this is how we do it in digital cinema every day, sending out the supplemental packages so that we don't actually have to create multiple flattened packages of the same content over and over again. So to give you something a little bit more complex, let's take a look at a French dubbed version of the movie. In that case, we might actually have a French title that's translated, and then also have some new French end credits on there. We would give credit to the French dialogue folks. So this would also make the movie a little bit longer, so there might be some extended music at the end. So we would have a new French audio track as well. We would have a new composition playlist that references all of these different pieces, again, to create this French dubbed version. But once again, we really only need to send just the differences between this French dubbed version and the English version, because we've already sent off the English package. So another example of a supplemental package. Now, you don't have to send supplemental packages. If you want to do a complete package that has everything in it, you can do that too. It's not a problem. And in this case, perhaps you want to add in a complex OPL. In this case, I have a set of instructions that creates an SD version from this HD version, and it creates a MPEG-4 low complexity with AAC audio. I could have this OPL point to any of these CPLs individually, or I could have it point to all three of them if I want. And that together could create your entire package that has all of the full assets in it. One more example I have is an airline edit or some sort of censored edit. Let's say in this movie that I have, there's a plane crash that happens right in the middle of the movie. Well, that's bad for airline edits, because obviously you wouldn't want to see a plane crash while you're watching a movie on a plane. So let's say we want to take that little piece out and basically butt together the rest of the feature together. And let's say that in the image it's okay to just cut out the sequence and it plays out just fine. But in the audio, perhaps there might be a snat or a dropout or something that happens when you try to butt those pieces of audio together. So we would go into the audio suite and have a new crossfade made that would actually fit and work with the other audio track. And then create a new composition playlist that basically creates this new airline edit. It would cut out that image that we don't want and then reference the crossfade for the audio. But once again, because the crossfade and the CPL are the only things that are different from the English, we can actually still just send this off as a separate supplemental or partial package for Deluxe or Technicolor to use, and they could reference back to the English package for the actual track files. So hopefully that makes sense for these different edits. So as you can see, IMF is a very flexible format that allows you to do a bunch of different versioning. You can do full packages or supplemental packages. But I had mentioned it before about the flexibility with the multiple codecs, and you might be wondering, well, how does that work? Well, at SMPTE, we decided to go with a modular approach. Originally, the USC ETC effort specified JPEG 2000 as the only image codec, but once this was brought into SMPTE, it was open for discussion, and so what we decided to do was basically create a core framework for IMF. The core framework contains anything that's common for the actual format, like the composition playlist, the MXF wrapping, and also any kind of major constraints that we would want to specify for the actual format. But then we decided to create these modular applications that basically plug into this core framework. And each of these applications would allow for specific functionality. For example, you could have higher compressed codecs, you could have certain resolutions or frame rates, and basically allows for different problems to be solved. So right now, under development, we have two applications. We have application 2 and application 3 that are being worked on for IMF. Application 2 is JPEG 2000 up to HD resolutions and frame rates. And application 3, which is an MPEG-4 simple studio profile that's up to 4K resolution. But the idea here is that from a manufacturer standpoint, depending on what application you decide to support for IMF, you would only need to interop or interchange within that application. So for example, if you were to create an implementation that used application 2, you wouldn't necessarily have to work with application 3. You just have to work with other application 2 implementers. And then you might actually be wondering what happened to application number 1. Application number 1 was originally an uncompressed version of IMF, but the proponents for application 2 and application 3 were a bit stronger, and so we decided to focus on those two applications and leave uncompressed for later. And then the idea here is that you can then add in other applications with other codecs or other resolutions and frame rates and that sort of thing. And that way, IMF is actually very much future-proof in that sense, because even though the core framework doesn't change, you can change some of the applications that are used. So now we're going to just jump into where we're at with SMPTE on the standards effort for IMF. The composition playlist and a document called Essence Component, which is the same thing as the MXF wrapping. Both of these two documents have passed the draft publication ballot back in July. So these documents should be published anytime now from the SMPTE headquarters. We have the JPEG 2000 application, the MPEG-4 Simple Studio Profile application, the audio and the core constraints standards starting their ballot process in October. And so those are working through the balloting process and comment period right now. We have started interchange and testing at SMPTE. This is a little bit different. I'm going to talk a little bit more about this in a couple of slides here, so just hold off on that one. And we've already started to work on the output profile lists for basically simple playout, audio routing, and transcoding. So just to give you a snapshot of where we're at in the different processes, we have these different documents on the left-hand side and also interchange testing. You can see that CPL and the MXF wrapping is done. These other documents are in progress right now, these other 5 documents. We're in progress for the interchange testing in the OPL, but we haven't actually started working on the pan scan metadata, color metadata, or descriptive metadata. So we've been kind of holding off on the dynamic metadata just to get the main part of IMF completed. But the documents that you see in red consist of the basic version of IMF that just gets it off the ground and running. So that was kind of the key that we were trying to do for the IMF format, was to make sure that we had a nice, good, strong foundation for the documents to move forward on. The other thing to note is that the SMPTE time text is also being updated by the W3C and SMPTE to add some additional functionality to the subtitling and captioning. But SMPTE time text, along with these other documents in red, is what you really want to have in order to have that basic IMF working. So the key to IMF adoption that we see is that obviously there needs to be software and hardware manufacturer support. So we need editing, transcoding, playback software. We do have many companies already interested, and a lot of the content owners that are proponents of IMF have been actively talking to other companies. But the other key, I think, to IMF adoption is this idea of having these plug fests during the development of these standards. So this is where manufacturers who are SMPTE members could create an IMF or an IMP from these draft documents. They interchange it with each other, and then anything that maybe is unclear or subject to interpretation can be clarified before the documents actually become final. So one of the unique groups that I do have in my working group is the Sample Material Interchange, or SMI, ad hoc group. The chair is a guy named Jerry Pierce, and he also does the interchange testing for a group called ISDCF on the digital cinema side. And the group has been working on interchange testing for application number 2. And we have 4 companies that are actually actively involved right now in creating IMFs and interchanging them with each other. And we've had a couple of different source files that Disney's provided to try and create this language versioning type of thing. And actually the group has found a few issues with the documentation where things weren't clear, and those issues were actually clarified before the documents have gone into the balloting process. So it's been very helpful having this interchange group. So I would encourage any manufacturer that has any sort of IMF creation or playback implementation to join this SMI group, and I'll tell you how to do that at the end of this presentation. So just to summarize, we're here at the end here. IMF did start as a need for a standardized file format for the distribution masters. It is loosely based on the digital cinema standards, but includes additional functionality for television. And also, IMF does allow for flexible versioning, as you can see, and it will allow for different codecs and try to do a little bit of future-proofing using these applications going forward in the future. And it is a suite of documents, and they are starting to be published very, very soon. So we're here at the Q&A stage. Let me just show you the next slide here. If you have any questions too after the webinar, you can contact me directly. Or if you are interested in joining the SMPTE effort or joining the Sample Material Interchange group, I highly encourage you to just join the 35 p.m. Media Packaging and Interchange Technology Committee. Then you would join my working group, and then under my working group is the Sample Material Interchange ad hoc group. So there you go. So Joel, I think we can take questions if there are any.
Very good. That was an excellent presentation. Thank you, Annie.
Thanks, Joel.
Let's see. First question in the queue. Is this IMF derived from the older OMF file format originally developed by Avid?
It is actually not. OMF is something completely different. And so IMF was, like I said before, it was originally called the Digital Video Package, or DVP. And it is more so derived from digital cinema than it is from any other format that's out there.
Okay. Next question. Would the CPL include less than 50, greater than 60 hertz instructions? And would it include repeat frame 2.2 and 3.2?
Ah, good questions. Yes, so the idea there is, for right now, it depends on the application. But for example, the application to JPEG 2000 covers both HD and SD. So it covers all the different frame rates too as well. So it's both PAL and NTSC frame rates, and you could have the repeat flag information as well, and that sort of stuff inside the CPL. So basically any of those frame rates that we have right now are supported in that. There is talk about extending that application too in order to have higher frame rates as well. And I'm not really sure exactly where the application 3 folks were going to go with these other higher frame rates. But the idea is that there's plenty of extensibility in the CPL to allow for multiple frame rates and different formats for the frame rates there. Sorry, I just kind of rambled there.
That's okay. Let's see. So our friend Eric asks, when IMF is ready, how do I author one? Let's say I have a finished show in Avid. Does Avid need to add the tools to make an IMF file?
Yeah, so Avid has been developing a method for creating IMFs. They've been doing something very similar now with certain content owners, content with the JPEG 2000 and the ASO2 MXF wrapping. So the idea is, from what I gather, it sounds like there would be basically an export to IMF or some type of method to just create that IMF from the Avid or from other, I guess you could say, quote-unquote, authoring systems or editing systems.
Okay. Is there an open source I/O library for IMF implemented in C++ and Java?
So I know that Cinecert, who are the creators of ASDCP lib for digital cinema, for the different tools there, they're actually in the process of creating the IMF version of that library, and they're planning to make that freely available. So if there are more questions about that, I can actually get whoever's interested in contact with John Hurst at Cinecert, and they could talk more about what those applications would be.
Okay. Are there any ideas or plans to use IMF for live use cases?
You know, I think IMF really is meant for store and forward applications. It's not that you can't use it for that, for a live application, but I think there's probably better workflows that maybe that news broadcasters and sports broadcasters already have in place. But if you would want to store it for an archive purpose, it might make more sense to put it into an IMF after you've captured it. But really the problem, just keep in mind that the problem that IMF was really trying to solve was that versioning problem that we have from the store and forward type of workflows as opposed to the live situation.
Great. What upstream system generates the instructional metadata that creates the OPL, CPL? Is that the edit system?
Yes. So In the case of these different manufacturers, like DVS would have it built into the clipster. You would have Ambertin would build it, but they would have a way to export out OPLs or these CPLs from their system as well. So the idea is, it's not that you have to actually create this XML by hand. The idea is you would be editing these pieces together like you normally would in a timeline, and then that system would actually then create the CPLs and OPLs for you from that.
Okay, our next question. Would descriptive video tracks be data essence or dynamic metadata? Where would they be placed?
I actually might need more clarification on that, because the descriptive video tracks are usually audio tracks, aren't they? That describe what's going on in the image, or is there some other type of DVS that I might be missing out on? Because if it's the audio track one, it would just be another audio track that could actually, and it's labeled through the multi-channel audio labeling specification. So you would just treat it as another audio track. But I guess if they have some other type of, I think of like how you would have a descriptive video track that's actually a, unless maybe there's, because usually descriptive video is for someone that's blind, so you can't actually read it. I might just need a little clarification on what they meant by what type of DVS I think they're talking about.
Okay, and I'll keep an eye out for the clarification if it comes in.
Great, thanks.
Next question. Are OPL encoding transcoding parameters designed to be easily mapped to FIMS requirements? And in parentheses, AMWA/EBU initiative?
Yes, yeah. So we've been really, those of us that working on the IMF have been in close contact with AMWA and the folks on the FIMS side. And there's really no reason why you can't incorporate in these OPLs into the FIMS framework. The OPL is a pretty early state right now, so we do encourage anyone that's interested from AMWA to get involved in the OPL group to make sure that we are on track. But like I said, we're just starting out with some simple examples of audio routing and some transcoding image manipulations. So once we actually have something down on paper, it might be great to have somebody from AMWA to take a look at it, because they're just a set of instructions, so I can't imagine that they would actually conflict with the FIMS workflow at all, or SOA.
Okay, and we did receive a response from Deborah Osborne, who submitted the question on descriptive video. It says the question was answered as it would be another audio track. Thank you.
Mm-hmm. Sure.
Okay, next question. Could you discuss again why the uncompressed application was removed from IMF?
Oh, okay. It wasn't removed. It was just that the way things work at SMPTE is you basically need a set of proponents to actually volunteer and do the work. And those that were involved were really interested in getting JPEG 2000 and this MPEG-4 Simple Studio Profile off the ground first. And then I think what happened is originally, like from the University of Southern California ETC document, we had always had uncompressed and JPEG 2000 involved. But then as things evolved and JPEG 2000 the application was worked on, the proponents realized that lossless J2K is as good as, or actually even better in some ways, than uncompressed. So we basically just kind of left uncompressed just kind of on the back burner. It's not that it's been removed from IMF, it's just that we haven't focused very much attention on it in order to focus the attention and just to get the JPEG 2000 application off the ground.
Thank you. And we'll take a few more questions here. There are still a few in the queue. Let's see. Will the standard comprise, in parentheses, now and in the future apps like pan, scan, etc., only metadata on how to operate on Essence, or actually mandate the low-level algorithms for that? For example, how to de-interlace, what algorithm to use for rescaling, and more importantly, interpolations for color space conversions?
I think as OPLs develop, I think we're going to get more specifics on those. In fact, I think you might end up getting OPLs that are specific to certain manufacturers, because then you know the output might be consistent, or you know that certain manufacturers have implemented specific types of filters and that sort of thing. So I think in the short term, we'll see OPLs that are more generic, a little less specific. But as people are getting more comfortable with the output profile list format and what you can do with it, I can see that it would get really specific. I know that, like I mentioned before, my example of Pixar with their color conversion from the 10-bit to the 8-bit side of things, they would really want to get super specific about, you know, this mean box filter, and you have to use this Lanczos filter, and you have to use this certain type of number of lobes, and you know, so I can see that. I think as we move forward on OPLs, they probably will get more and more specific. But then again, the idea is also, if you want to have more interoperability with different manufacturers, there's probably only a certain level of specificity that you can actually get down to before it might get a little too difficult for a manufacturer to interpret.
Okay, thank you. And the questions keep coming in, and I think we're probably going to take one more question live, and ask Annie, if would you be able to answer at least some of the questions that we don't get to, say offline, send responses to me, and we can distribute them?
Sure, that sounds great.
Okay, good. The last question for today then would be, let's see, would a 3D production be supported by IMF, and would that just be double the essences?
Oh, yes, yes. The stereoscopic is definitely supported. The idea would be, we actually had a lot of discussion on whether it should be interleaved or separate tracks. I think from a simplicity standpoint, it would be separate track files. So you'd have a left eye and a right eye track file within a composition. They need to be the same frame rate in order to work in that composition. But the idea is they're not separate IMFs, they're within the same IMF.
Okay, great. Thank you. I do want to thank you for taking time to put this together, Annie, and I think it's one of the better webcasts that we've had in both the Standards and the PDA Now program, partly because it was so visual and so animated. Thank you.
And I'm sorry, like I said, I feel like this is, just because I'm a little sick, it's not as punchy and as spunky as I wanted it to be.
My goodness.
But hopefully people found some humor in it, and I hope you enjoyed the webcast. And yes, I'd love to answer any questions offline.
Excellent, excellent. Thank you. Thank you, Annie. Thank you to our guests. With that, we will close today's webcast and hope that you'll join us next time. Thank you, everybody. Look forward to seeing you next time.